I currently have the default stress plot activated. Notice next to the plot name, the term von Mises is shown. Von Mises stress is a way of representing stress levels that is not specific to direction and is useful in calculating yield conditions. Without getting too deep into the mathematics, von Mises stress is calculated using principal stresses. I mention this because in some cases you may be interested in principal stresses or other stress components instead of von Mises stress. Simulation gives you the ability to display stress in whichever way is most useful to you. You can either change an existing plot like the one we have here, or you can create a new plot. If you wanted to change an existing plot, all you have to do is right-click the name of the plot and select Edit Definition. In this case, I'll be creating a new plot to examine the first principal stress. To begin a new plot, I can right-click the Results folder in the Simulation Study Tree and choose Define Stress Plot, or I can go to the drop-down of the Results icon, New Plot, then select Stress. Next, you'll see a drop-down list that gives you access to the different stress components, including principal stress, shear stress, and normal stress. In my case, I wish to display the first, principal stress. I would like the stress magnitude to be shown in megapascals, so I'll change the units accordingly. Next, you see a setting for either node values or element values. The differences between these values are more complex than I wish to get into in this course. But the short explanation is that when stress values are calculated for each individual element in the mesh, they must be combined using some mathematical technique. Each of these options uses a different mathematical technique for the combination. Node values produce smooth fringe plots, while element values produce rough fringe plots. Node values will always be different than element values, although the differences should be small. In fact, a large difference between these values is an indication that the mesh being used is not fine enough. So examining these two different values can be a troubleshooting technique. I'll leave this setting on node values. Next, we have the deformed shape settings. This is where the exaggeration of the deformed shape is controlled. You can either have simulation automatically assign a scale factor, or you can enter one manually. I'll let simulation calculate this for me. The last group of settings in the Stress Plot Manager has to do with the visual appearance of the plot. You can include a title for the plot, and if you wish to tie the plot to a specific view orientation such as front, top, right, or another view that best shows your plot, you can specify that here as well. I'll enter a title of First Principal Stress, and I'll associate the plot with the isometric view. Now at this point, I'll simply click OK, and the stress plot showing first principal stresses will be created and displayed. You can see the title of the plot appears on the upper left, and the values are shown in megapascals, just as I specified. The plot is listed as Stress 2 in the Results folder. As with other items in the Simulation Study Tree, you can slow double-click to change the name of the plots to a more descriptive name. The labels next to the plot names provide enough information for me here, so I'll leave the default names. To switch between the two plots, simply double-click on the plot you wish to activate. Finally, notice that if the part is in a view other than isometric, when I activate Plot 2, the view is automatically changed to isometric.